See, like I say, one of the things what they were wondering about, what everyone was wondering about, was how do I get such speed out of the Titanic? They asked the physics people and everything else like that. The Titanic shape was kind of an unusual shape. It was a very simple shape. Basically, it was just a big flat bottom and a nice good front end, flat front end. And I had some others where I had kind of like a pointy in the front that would kind of cut the wave. It's the way the wave works. When you have a ship that's like this and is flat on the bottom, this actually, believe it or not, there's something about the way this shape works. See, in the past, I had always done. Most people do this big rounded shape like this, and this shape really doesn't work that well. Because, well, the way the water works, I mean, I've tried every shape possible known to man. Every shape known to man, I've tried. Like I said, Lucifer Star is the name. Particle Creation's the game. Epic things like creating this from sun particles. By the way, like I say, the sun, it's particles from the sun. Yeah, cool, huh? Anyway, so everyone was wondering. This shape actually did pretty good too. Like I said, 150 ships back in the old glass building days when they had the big glass building and they were showing off all the different stuff that I had built around the world from all my different factories. They had my shipping. They had my ships. You know, the table with the little elephant's feet, and then there was all these ship models on the top. LS Titanic or LS Star. I mean, blah. Lucifer Star. It's my name, literally my name. Anyway, so they were wondering how I got so much speed. I tried this shape, and then on the Titanic we were trying something a little more simple, but this shape seemed to work pretty good because the way the waves work is the waves kind of go over it, and you know this shape worked really well too. It was one of the better shapes. I mean, nowadays we do the rounded bulb thing on the front, and that does the same thing basically, but I was doing more of a knife, and this is actually for going through ice, although it's better. You can go through thicker ice if you go on top of the ice. We know that now because of me. Anyway though, but everyone was wondering, how do I get such speed out of the Titanic? It shouldn't be possible, even with the turbine, and how do I have enough steam to run the turbine? And the truth was, the turbine was used really small, really sharp blades. They're really close together, actually. So not a lot of air could easily go through it, actually, without it spinning. And actually, the way it worked is that the steam first went through the turbine, and then, well, you could shunt it either way. You could shunt it directly into the turbine, all of it going into the turbine, and then take it through the reciprocating expansion engines. See, the way it would work is it would go at pressure through the turbine, and then it would go through the, oh wait, no, that's right. No, with turbines you want to have no pressure behind you. Anyway, basically the steam would go from the boilers to the engines and then to the turbine, or something like that. So it's basically like recycling steam, pretty much, and then it would just blast out. You know, I forget. It was a maximum use of the steam, basically. So it went at pressure through all these other places, and then it just zipped out the turbine. So and out, yeah. So you use maximum, yeah. So first it went through the engines, and then so it went from, well, you could shunt it directly to the turbine, but it was better to go through the engines and then the turbine. So anyway, but the point is though that it would go from here to the triple expansions, and then it would go to the turbine, and then out, and then that way you get maximum use of your steam. So a maximum use of your power. It's like getting 3 times the amount of power from the steam, basically. So, or 4 times power, basically. And then on top of all that, there was turbo, which was like I say, what you do is you load up the coal all the way on the engines, basically. and then you shut the doors. Now, normally the coal would be stifled, and you would have just stifled the fire, and you'd get less power. But what we do though is after you shut the doors, you hit the button that turns on the alcohol and oil shunting, and then we would pump air through here. See, most of the time it just uses it just uses what's called, but the Titanic had turbo function, which is basically where we're pumping, you know, so you fill up these things all the way, and then all the way up to the spigots, and that's another thing that you would hear is they would say stuff like fill it up to the spigots, so they would fill it all the way up to the spigots, so there's just a little bit of airflow through, and then basically they would shut the doors, and then they would turn on the oil pumps, and the oil pumps would start pumping oil into the chamber, and then at the same time you turn on the fans, and the fans blow air through the chambers, and basically what you get is a blast furnace. Yeah, that's why, and that's another thing too, is that the actual chambers weren't all that big. There are a couple of different designs of LS steam engines, but this was one of the, I forgot about this one, but this one was one of the best. I mean, we started out with just an open bottom and all that stuff, but anyway, this one allows for lots of water to get around it, basically. And then like I say, you use the blast furnace function, and basically you shut the doors, the blast furnace turns on, and it's blowing air through here, and then you're adding oil and alcohol on top of that. So what you get is a really hot, like, fire. And that's the turbo function for the Titanic. And with that, you can get, we got the speed out of it. 40, 50, 60 knots. I think it could do 60 knots at maximum. Yeah! Which is like 80 miles an hour or something like that. The Titanic was really, really, really fast. People were like, how does it move that fast? It would literally go through the water. And it was kind of a lighter ship. It was one of the lighter designs, really. Anyway, but that was the LS Titanic. And also, too, the amount of coal that we used was a lot less because we're burning it hotter. And you could even use wood with it if you wanted to, but it's sooty. Like I say, the LS Titanic, Lucifer Star Titanic, we only used about a third of the coal. Going from Belfast or whatever, from England, all the way to America, the maximum trip. We only used, or New York basically, we only used a third of the coal. Of the total amount of coal, which was a lot, they estimated we could get 3 or 4 trips out of that amount of coal. It got really good coal mileage. I mean, really good, like unheard of coal mileage. And it only burned a little bit of alcohol too. By combining the coal and oil and the air, by using the blast furnace function, it actually did really, really good on coal. It was the perfect amount. With a good engineer could basically. They even said one time that it actually only used a quarter of the coal, like 1/4 of its coal reserve, basically. So anyway, yeah, it was a success. It was a hit. It got ridiculously good coal mileage, ridiculously good, and it didn't even burn that much alcohol either. A fair amount, but not that much. And besides, it's using oil or waste oil and alcohol. So anyway, yeah, it was basically it's like 1/3 oil alcohol, or like 2/3, half alcohol and 1/3 oil. My engineers and my people would mess around with the mixtures and be like, yes, and this gives a maximum. Yeah, like I paid my people really well, and they really, really put out. I mean, they had that ship humming like perfect. So anyway, it helps to pay your people really well because they really get good at what they're doing. So anyway, so yeah, the LS Titanic, it was a really ridiculously good ship, and more than proved itself. And like, it actually held a lot of cargo. Like most, like 1/3 or 2/3 or the whole bottom deck was basically a big cargo deck.